Again, today we're going to be doing K2, which is exponents with the same base. Tomorrow we'll be talking about power property. Thursday we'll be doing some individual whiteboard practice and taking a formative. On the right side of your notes, there's this chart. Okay? So we're going to start by filling that in, and then we'll go back to reminding ourselves of what an exponent truly is. Okay? All right? So 2 to the first power is just 2, right? Okay. What does 2 to the second power, or 2 squared, what does that mean from yesterday? What does this 2 squared, what does that mean right there? I know it's equal to 4, but what does it truly mean from yesterday? Literally look back in your notes. Turn your page, flip it over. Turn your packet, flip it over. If it's in your binder, turn your page back one. What does 2 squared mean in math? What does 2 squared mean in math? Once again, turn your page over to K1 and look for it. So 2 squared means 2 times 2. Okay? What does 2 cubed mean? Or 2 to the third power. What does that mean? Up, nope, 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 up. Too high, too high, down. One this way. There you go. What does 2 cubed mean? 2 times 2 times 2. What does 2 to the fourth power mean? We got Bryce. 4, I think you gave me 4 of them there. Okay. So let's go back up here now. So what does an exponent mean then? Or what does an exponent do for the base? Exactly. The exponent tells us the number of times you multiply the base by itself. So in this first one, in 2 squared, the exponent was 2, so that's why we went 2 2s. In the next one, the exponent was 3, that's why we went 2 3 or 3 2s. Next one it was 4, so we went 4 2s. Okay? And so on and so forth. So 2 cubed means 2 times 2 times 2. What does x to the fourth mean? Maybe 4 of them there. Yep. Means I need 4 x's, all multiplied by each other. Okay. All right. So now let's fill in this table. So 2 to the first power is 2. We got that. 2 squared is 4. 2 times 2. 2 cubed is 8. 2 times 2 times 2. Okay. What is 2 to the fourth power? 16, because 2 times 2 is 4, times 2 is 8, times 2 is 16. I would concur that this is 16. Okay? What would 2 to the 5th power be? Two to the 5th power. We can use a calculator, it's fine. What do we got, Cor? 2 to the 5th power. 2 caret 5 equals 32. Two to the 6th power. 64. Yeah. 2 to the 7th power. 128. 2 to the 8th power. 256. How'd you get it? Because you did it without a calculator. But you did it without a calculator. How'd you get it? Multiply by 2, right? Yeah. Notice how all these were multiplied by 2. Okay? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. 128 times 2 is 256. Yeah, we're just doubling that. Yeah. If it were 3, we'd be multiplying by 3 every single time. Yeah, exactly. Good job. 2 to the 9th. So now that we've got that chart filled in, okay, now let's go in, we're going to use the table to figure out all of this. Okay? So we kind of gave it away there. 2 to the 8th times what gets me 2 to the 9th? How did Gibson get 2 to the 9th is 512, from 2 to the 8th is 256. Literally just said. What are we doing? Every single time. Which is in math. In math, I only know add, subtract, multiply, divide. Double's not one of them. By 2. Yep, exactly. So we multiplied here by 2. Well, in my chart, 2 is the same as 2 to the 1st power. Okay. 2 to the 1st power is 2. 2 to the 5th power is 32. What times 2, the what, that box, what times 2 is 32? $16. Okay? So 16 would go in here, right? Where does 16 fall on our chart? 2 to the 4th power. This is 2 to the 4th power. So 2 to the 8th power times 2 to the 1st power is 1. Excuse me. Said that. 2 to the 8th power times 2 to the 1st power is 2 to the 9th power. 2 to the 1st power times 2 to the 4th power is 2 to the 5th power. Okay? Same thing down here in this one. 2 to the 1st power times something gets me 2 to the 6th power, which is 64. What times 2 gets me 64? 32, okay? Or we could do 64 divided by 2. No, 32. And 32 is what? 2 to the 5th power. In MathCloud, there's always a pattern. Okay? Sometimes the pattern is hard to see. Sometimes the pattern is easy to see. Okay? Do you see a pattern in those 3 that we just did? Okay, because we're all multiplying by 2's. Yep. Okay. Anybody see another pattern? Like I said, sometimes the patterns are easy to see. Sometimes the patterns are not so easy to see. Anybody see one yet? Try this next one. 2 to the 4th. What can I write 2 to the 4th as? 16, right over there in my chart. This is going to be 16 times something is going to equal 2 to the 7th. What can I write 2 to the 7th as? 128. Okay? Now, this one we might need a calculator for. 16 times what number gets me 128? Or, another way of saying it is 128 divided by 16. Gets me what? What do you got? 8. Other people confirm that it's 8? Anybody with a calculator reconfirming that it's 8? Bryce, can you confirm that it's 8? 128 divided by 16? You haven't done it yet. So you can't say yes when you haven't confirmed it yet. Yes? All right. So we got 8 here. 8 is also what? What multiple of 2? What multiple of 2? It's in our chart. 2 to the 3rd power. Okay, not just 3. 2 to the 3rd power. Okay? So with that being said, does anybody see a pattern yet? All of those 4 are true statements. What do you got, Ash? Like, what do you mean that they're equal? Yep. Does that follow in the second one? 1 plus 4 is 5. Yep. Does it follow in the third one? 4 plus 3 is 7. Does it follow in the fourth one? 1 plus 5 is 6. Yeah. That's kind of a cool pattern, isn't it? Okay. What Ash just told us is this number here plus that number there gets me that number right there. 4 plus 3 gets me 7. 1 plus 4 gets me 5. 1 plus 5 gets me 6. Okay? And that is a pattern. And that pattern will always work no matter what so the product of powers property, the kicker is, has to be the same base. This doesn't work if they're not the same base. Okay? So put stars around the same base. Okay? Put stars around the same base. Put stars around the same base. Put stars around the same base. Has to be the same base. If they're the same base and we are multiplying, then we add the exponents. If they're not the same base, you can't do this. It only works if they're the same base. So for instance, in the line right above that, if the variables are like x squared times x to the 5th power, right here, x squared times x to the 5th power, do we have the same base? Yeah, because they're both x's, right? Okay. So the base, remember, is the number below the exponent. If those are the same, then we add the exponent. So what is 2 plus 5? 7. So this is x to the 7th power. Right there. We add the exponents. Multiplying with the same base, we add the exponents. Okay. Number 1. First question we ought to ask in APA, do we have the same base? Yes, we have the same base. So because we have the same base, Ms. Lagway, what do we do with our exponents? We add them together. 15 plus 3 is? It's 18. I'm not going to ask you to go on a calculator and do what 3 to the 18th power is, because it is ginormous. Okay? Right? So we're just going to leave that as 3 to the 18th power. Okay? All right? Mr. Bell, question for you. Do I have the same bases? Yes, I do. Okay? Miss Izzy, what are my 2 exponents? 2 is the first one. What's the exponent on the second 6? What's the exponent right here on that one? There's what? So do you remember yesterday what we said when there's nothing there in terms of the exponent? What it is? Well, how many 6's do you have just in that one? 1. So what would the exponent be? How many x's or how many 6's do you have? 1. So what's the exponent? 1. There you go! The exponent there is 1, right? So Mr. Bell told us that, Mr. Bell told us we had the same base, right? So we can add the exponents, right? 2 plus 1. 3. So it's 6 to the 3rd power. You got all excited there because you finally realized that you knew what you were talking about and I was just trying to pull it out. Okay? Alright? Ash. Same exponent, or excuse me, not same exponent. Same base in number 3? Yes. Good. What do I do with the exponents? Add them. 3 plus 4. 7, right? So this is going to be j to the 7th power. Okay. Cloud. Same exponents in number 4. Or I keep saying same exponent. Same base in number 4. Can we rewrite it? Because does order matter in multiplication? Meaning, if I had 3 numbers, give me any 3 numbers. Right? If I multiply 5 times 6 times 7, I'm going to get some number, right? 210. Okay? Right? If I multiply 6 times 5 times 7, am I still going to get 210? Yeah. If I multiply 7 times 5 times 6, all the same numbers, right? So it doesn't matter what order we multiply them in, right? Okay? So can I rewrite this as a squared times a times b cubed? Can I do it? Yeah, okay. So, Kong Meng, back to his original question. Do I have the same base all the way through? No, I don't. Do I have two of the same bases? Yeah, so the a's, right? Now, Izzy told us that there is an exponent of 1 on that a. Right, Iz? There's an exponent of 1 on just that a? Because it's just there, it's just 1a? Yep, okay. So 2 plus 1 is 3. So then this one becomes a cubed b cubed. That's right. Can I go any further with this particular problem? No, because the bases aren't the same, right? Exactly. We can only go further if the bases are the same. Okay. Everybody with me so far? Love. Ooh, Gibson, kicking it up a notch. Okay. What's the exponent on the, well, first off, first question, do I have the same base? In number 7, or number 5 here. Same base. Yeah, they're both a's, right? So they're the same, okay? What was the rule that we learned on the bottom of the last page? We started, you can flip your page over, it's okay, I'll let you. Way down there at the bottom, what's the rule? Same base, so if we're multiplying, we add the exponents, right? Okay, so what's the first exponent? Z, what's the second exponent? 3. Bryce. Gibson just told you that the rule is if we have the same base, which he said that we did, you agree? That we add the exponent, right? Okay. So this is going to be a to what power? What's the first exponent? What's the second exponent? So if I add z and 3, what do I get? I'm going to forget about the z. It's kind of a trick question, but it's not really a trick question. If you have z pencils, and I give you 3 more pencils, how many pencils do you have? Not 3 times z. No. Asha? What's the exponent going to be? First exponent was z, second exponent was 3. Gibson and Bryce both confirmed that we add the exponents. What's the exponent going to be? Z, that's times again. How do we say add in that? Give me another word, starts with a P. Yeah, you do. What's another word for math in math? It means addition. It starts with P. Lost it. Ureli, we're up to you. Give me another word in math that starts with P and means addition. Got it? What do you got? Plus. Okay? So what am I going to do with z and 3? So I'm going to write z plus 3. Huh? Back to you, really. Same base in number 6. Yes? Okay, so what can we do with the exponent? We can add them. Yep, okay, so what's my answer going to be? If I've got 7 to the a power times 7 to the b power, that's going to end up being as my, so it's going to be 7 to the a plus b power, or it's just going to be a plus b? Give me another chance. Because we got to have the base in there yet, right? So we're still going to have the 7, and then our exponent is going to be a plus b. Okay, because we add them in the exponent spot. 7 to the a plus b power. Okay? All right? So this next one's kind of, I noticed it after the fact that we had them copied up, so I didn't go back and I didn't change them. But this next one's kind of a little goofy. Like, I almost want to say like this. Because I want this down there. We want to solve that equation for A. Okay? All right? Jesus. Looking just at the left side. Right? So I'm looking just here. Do I have the same base? Yes. What do I do with the exponents? We add them, right? Because we're multiplying, we add the exponents. And 4 plus 7 is 11. So this left side right here is 2 to the 11th power. Right? Okay. Now, Cora, that said that this was equal to 2 to the a power. Agree with that? If I simplify the left side, then that's going to equal the right side. With me? What does a have to equal to make this purpley blue, black, I almost said purpley blue, purpley black statement true? What would a have to be? 11, right? To make those be equal? Yeah, exactly. So a here is 11. To make that be true. Yeah. Once again. This logo. Do we have the same base on the left side? Yeah? Okay. What would the left side simplify to be? 5, right? To the what power? Nope, that's just the one. That's just this one. If we just say 5 to the c power, then we're totally disregarding this. Plus 3. So this side right here becomes 5 to the c plus 3 power. Network not accessible. Oh, okay, guess what? Network is now connected. I was so worried there for so long. Okay? Think you can handle it? So let's go back. Let's go back one problem. Okay? Over here, we said that 11 was equal to a. Right? The exponents had to be equal. So over here, the exponents are going to have to be equal again, correct? So can I say this? Yeah? Yeah. And then how do I solve this one for C? Anybody? I want to solve that equation for C, the blue equation for C. How do I solve it for C? Minus 3. Yep, I subtract 3 from both sides. And C here is equal to 7. 3 minutes left, and so we're going to talk a little bit about these ones now. Okay? So how I go about recommending you rewrite these ones is I would take the numbers here. So we've got 3 is a number, 6 is a number. So we write those two next to one another. We're kind of grouping the like things. Okay? So we got 6 times 3. Then we've got m squared and we've got m. So that's going to be 3 m's. Then we've got 2 peas in a pod. Okay? So we've got everything that we needed, and now we go through. 6 times 3 is 18. 3 m's. How could I write 3 m's? How could I write these green 3 m's? What you got is m to the 3 power. Yes. The 2 blue peas. P squared. Yeah, and that's my answer right there. That's how I do those. Okay. I think we can quickly do number 10. Don't you? We got a 3, and we got a negative 5. What is 3 times negative 5? Negative 15. We've got an x, and we've got 2 more x's. So how many x's total do we have? 3, so that's going to be x cubed. We got 2 y's and another y. How many total y's do we have? 3. So that's going to be y cubed. Okay? Good times. Oh, I thought we were going easy on you. We only did one side, but then I flipped it over, and there it was. More stuff. If you didn't turn in K1 yet, make sure that you turn in K1 before you leave. Because remember, all of you promised me that you were going to turn in homework today, and that we weren't going to have so many missing assignments this unit. I heard you. All of you said that. You said it too. That everybody was turning in homework today.
I did.
That's good.
Yeah.
Have a good day.